31 or 32.
Okay. Okay. Anyone have a preference, 31 or 32?
I gotta look at the
It's the ones where you have to write a recursive definition.
32.
32, that's kind of what I thought you'd pick. So 32 gives you a list of numbers and it wants you to write a recursive definition or a recursive formula. Remember, a recursive definition always starts with one thing. What does it start with? Say it again. Is that Izzy? Starts with what? Okay. So we have to write a rule for T sub n. But before we do, we have to list one thing. When we write a recursive formula, it always has two pieces. What's the first piece always? Okay, look at problem 27 and 28. Those are recursive. Those are recursive formulas. We have to write something like that. So what do we have to start by stating? What do you think, Nathan?
Like the first term
The
is equal to.
First term, yes. Okay, so we have to start by saying T1 equals negative 2. You always have to start with that. Now we're going to write our formula for Tn, T sub n. And what this means is we're going to take the previous term. So how do I show the previous term? T sub n minus 1. And what's happening in this sequence from term to term?
Subtracting
And
75.
Oh, careful. All right, so I hear some controversy, adding or subtracting. Are the numbers getting bigger or smaller?
Smaller.
Smaller. We are subtracting 0.75. Okay? So this is how we would write our recursive definition, is our initial term, and then we take away 0.75 each time. Listen, this is Trig now. Hi. Oh. Yes, absolutely. Yep. Hi. Okay. Sorry about that. So that's it. That's it for number 32. What else you want to see? Macy.
Can you do 28?
28, sure. So 28 gives you a sub 1 is 2. Hey guys, we're awfully chatty today. Think we can rein that in a little bit? Negative 2 plus 3 times a sub n minus 1. Okay, so we want the first 5 terms in the sequence. What's nice about this is we already have the first one, right? So a1 equals 2. Our first term equals 2. When I go to look for term 2, what am I going to do? Okay, so I'm using this formula. So I'm going to do negative 2 plus 3 times, and this always means look up at the term above. Okay, so 3 times 2. Let's see, that's 6 plus negative 2, which is 4. Follow that, okay? So then when I go to find term 3, negative 2 plus 3 times term above, so 3 times 4, that's 12, negative 2, that makes 10. Okay? A4, oh, Allie. She told me your name was Alex. I'm just confused. What were they were talking about? Sorry, I forgot to leave this down. Just write my name on the top of that, okay? Okay, so for term 4, I'm doing negative 2 plus 3 times the term before, so 3 times 10. That's 30, negative 2, that'd be 28. And then term 5, negative 2 plus 3 times the term above, which is 28. Oh gosh, this is 90.
82.
No, I wouldn't be doing it in my head.
I was getting there in my head. You guys are too fast for me.
forgot to add.
But I think this is going to be 84, and then negative 2 would make it 82. So here are your terms in the sequence. 2, 4, 10, 28, 82. Okay? Anyone struggling with how I found those? Because I know that was a little segmented. You okay? All right, what else you want to see? And if you haven't gotten all the way through the review, it'd be a good idea for you to kind of skim through the rest of it and look for problems that if they showed up on your test, you would have no idea what to do.
33.
Izzy?
I was just gonna ask if you could generally go over something, but
Okay, let's hit 33, and then, yeah, I'd be happy to. So 33. Okay, does the table describe y as a function of x? I want to review this wording with you.
Yep.
When it's written this way, which one is the independent? The x. It's whatever it's a function of, this is the independent variable, and this is the dependent. So which one do we care about repeating? For a function,
No.
which one can't repeat? The independent cannot repeat if it's a function, okay? Because you can't have one of these that's paired up with more than one of these. So you can't have like 1 matched up with 5 and 7. So looking at this table, I want to look at the x's. Do I have any x's that are double paired? What is? The negative 1. Yeah, negative 1 is paired up with 1 and negative 1. Do you see what I'm talking about in the table? So this would be no, it is not a function. Okay. Okay, Izzy, what did you want me to talk about?
I was just that.
Oh, the function in the tables? Awesome. Okay. What else you want to see? Which one?
One of the solving for a variable.
Okay, so like 11 through 18, those ones? Oh, no, you mean like
You have
isolating a variable.
Yeah, isolate.
Okay, so like for example, number 19, number 20, anyone have a preference on one of those? Which one?
24.
24. Oh yeah, 24 is a good one.
20.
Okay. So 24, area equals 1/2 h times b1 plus b2. This one looks drastically different depending on which variable you're solving for. Okay, so just be careful with it. In this one, it's telling me to solve for h. By the way, see how it says solve for h? What does that mean? Get h by itself, right? H equals blah, blah, blah. The other way that same thing could be worded is it might say, rewrite the formula for h in terms of b1, b2, and a, for example. It's a lot wordier, right? But when I say rewrite it for h, that means get h by itself, okay? And then put the other things on the other side. And then when it says in terms of whatever, that just means that's what's going to be on the other side. Okay, so somebody name something I need to get rid of here. Tanner,
Fraction,
how you want to do it?
multiplied by reciprocal.
Okay, let's multiply by 2, which is the same as 2 over 1. So now that's 2a over here. This is gone, and I have h times b1 plus b2. All right, what do I still need to get rid of? Matt.
B1 and B2.
Okay, and what's nice about that is, see how those are in parentheses? Those parentheses make that so it's like all one big piece. So if you don't have to separate anything in there, if it's not like one of those things that you're solving for, you can treat that all as one thing. How is that one thing attached to the h? Hunter?
Why do you multiply by 2?
Well, because 2 is really the same as 2 over 1. And if I do 2 over 1 times 1 over 2, and I multiply straight across, I get 2 over 2, which equals 1. Which really, when we're talking multiplication, because that's the identity, if I had a 1 sitting out here, it doesn't matter, right? So I'm trying to cancel that out. Technically, what I'm doing is multiplying by the reciprocal, 2 over 1. I just write it as just a 2.
Okay.
Okay? Good question, though. Glad you asked. Okay, so how is h attached to the parentheses? Haley? So how do you want to get rid of it? Yep, divide everything by the parentheses. Divide by b1 plus b2. And divide by b1 plus b2. Gone and gone. And so now I have h equals 2a over b1 plus b2. And that's how you would solve for h. What else would you like to see? I don't know what all that junk was. Cam?
Back to 33.
Mhm.
Which one would be the output and
Oh, good question.
the range?
Okay, so the input is the independent variable. So it's what you're plugging in for x, and then the output would be your y. Okay, and then the domain is always your input or your independent, and your range is always your output. So to kind of sum that up, let's put all of those things together. Typically, in a problem where you're dealing with x and y, okay, the x is your independent, the domain is your possible values of x, and then this is the number that you're plugging in. That's what makes it the independent variable, by the way, is that that's the number that you're putting in, and then the value of the other one depends on what you plug in. So this is the dependent variable. The y values are called the range, and then this is the output. Thank you for asking that question so I could pull all of those together for you. So x is what you're plugging in for, okay? So that's independent because you can put in anything you want. The y is dependent because you get your answer out and your answer depends on what you plugged in. Tanner?
Like looking at the graph or the table, how can you tell like that you're putting something in for x? Like how can you tell x is?
Like which one's which?
Yeah.
So like looking at number 33, it's all about this wording, y as a function of x. When it's worded that as a function of x, that's telling you that you want x to be your independent. I would say 95% of the time, the one on top is your independent and the one on bottom is your dependent. But there was that one on your quiz where they switched it around on you, so you just got to be careful for that.
Right.
But yeah, it's if you're dealing with x and y, x is your independent and y is your dependent. If it's other variables, you may have to just be a little bit more careful about that. But that's a good question. On a graph, the x is always your independent and the y is always your dependent. Macy?
Can you do 41?
Sure. Are we good on this stuff? Anyone feel like they need to talk about this a little more? Okay. 41. So 41 gives me the equation, and I was talking about this one, I think, with Matt a little while ago. Gives me the equation y equals x to the fourth. And the first question, part A, wants to know the domain. What am I asking when I ask domain?
What are they?
What can x be? What are the possible values of x? So what am I allowed to put in there for x? Everything. I can put positives, negatives, zero, fractions, decimals. Anything I want, I can raise to the fourth power. There's really no restrictions here. So my domain is all real numbers. Now the question they ask in part B is really trying to lead you to the answer in part C. Okay? Part B says, are there any values of x for where this comes out negative? So I want to know, is there something that I could put in here and raise to the power of 4 and have it come out to be a negative something? Is that possible? Logan?
Put negative numbers.
Okay, so let's put negative 3 into the power of 4. Now, before you touch your calculator, let's think about what that's really saying. Okay? Negative 3 to the power of 4 means this, right? Negative 3 times negative 3 times negative 3 times negative 3. Even if you don't know the answer numerically, what do you know about your answer? Izzy?
It's going to be positive
Why?
because the negative signs cancel.
Okay, so 2 negatives make a positive, right? 2 negatives make a positive, and then when I multiply the positives, I get a positive 81. Okay? So if I have 4 negatives, it's going to make a positive. Do I have any other way I could make a negative? If I plug in a negative, I get a positive. If I plug in a positive, I get a positive. So can I get any negatives? No. Okay, so this is not possible. Not when it's a power of 4. What if it was a power of 5? Yeah, then that's no problem, right? Because if you have 5 negatives, your answer will end up negative. Okay, but this is not possible. There's no way to get a negative answer, a negative output. So for C, where it asks the range, remember that's what that's asking. When it says what is the range, I'm asking you what kind of answers can you get. Logan?
All real numbers greater than or equal to 0.
Good, and I like the way you said that. A lot of people say, oh, you can get all positive numbers. Okay, that's true. That's really, really close. What's the problem with just saying positive numbers?
Doesn't include 0.
Doesn't include the 0, right? So if I write it this way, that includes 0. Okay, because you can get 0 as an answer if you plug in a 0. You just can't get anything negative. Okay, Haley?
52.
52. Okay. Todd works out at a gym 3 times a week, and he has a trainer that measures his bicep every week. That is the most ridiculous thing I've ever heard. Okay? When he first started training, his bicep was a measly 12 inches around. Boo. Okay? But he added a quarter of an inch every month. Okay? So we're starting at 12 inches
It's the story of Paul.
and adding
It's my father.
a quarter inch every
Based
month.
off a true story.
I'm just kind of summing up here what the problem's talking about. Okay, so we want to write an equation that gives the circumference after m months. Okay, so for part A, the circumference, we're writing an equation for the circumference. So notice how I start with C. Where's my circumference starting? 12, weakling. Okay, 12. And then how do I show this part? That I'm adding a quarter inch per month.
1/4 x.
Okay, plus, and I think in the problem it actually says m, so I'm going to use m. Do I care one bit if you put x instead? I don't.
You changed the 1/4 to 1/25.
Sure, yeah, you could do that. So there's your equation. That's the equation that it wanted. I don't care if you use different letters. I don't care if you use x and y instead of c and m. What I do care about is don't try to cram all of those letters in there at the same time. Sometimes I have people trying to use x and y and c and m. Remember, these letters are like a substitute for those. Okay, what would the measurement be at the end of 2 years? So for 2 years, what am I plugging in?
20.
Okay, well, first of all, I have to convert that to months, right? And then I'm going to put it in for m.
Question, what if it's a leap year?
Ooh.
You know, it just says a quarter of an inch a month. It doesn't seem to matter how many days are in the month. So maybe he just takes a day
wrong.
off from
That's
the
not-
gym.
It's not consistent. This is some months up there.
Does that make sense why I put the 24 there? That's 24 months, and so I'm plugging 24 in for m. Okay, 1/4 times 24 is 6, so this is really 12 plus 6, which is 18 inches. So at the end of 2 years, his arm is 1.5 feet around.
Oh.
Baloney.
That seems really big.
Weak.
Okay, C. That's a great question. Hey, read part C. Read part C in number 52. What do you think? Think we could extend out to 5 years?
I don't think so.
Why not?
There's a cap in muscle.
Yeah, because there's kind of a limit to what your body's going to do, right? The guy might give himself a heart attack trying to get up to whatever it would be after 5 years. But no, biologically, there's only so much muscle mass you can physically build. Okay, so it's true. So I would say probably not. This is probably not a practical thing long term. You know, it probably describes it over a set number of months, and then maybe he's going to start focusing on, I don't know, his quads or something like that. He's
Leg
thinking-
day. Leg day. Son Taylor Whitaker doesn't do.
Oh my goodness. Okay, what else you want to talk about?
She's like, oh, I know. It's true.
James.
58.
58. Is someone watching time for me?
Yeah, it's
I'm
12:36.
I knew someone would be watching. Okay.
Thursday, October 1.
58. Okay, so looking at number 58, Central High School, let's start with our variable. What is x going to represent in number 58? Oh, Haley?
How many students are
Okay, so the total student body, or total student population. And please notice that this school only has grades 10 through 12. Okay, so don't stress out about those freshmen. 2/5 of the students are in grade 10. How do I show the sophomores? How do I show 2/5 of the students? 2/5 x. How do I show the juniors? 1/3 are in grade 11. How do I show juniors? 1/3 x. And then 320 of them are seniors. How do I show the seniors?
Plus 320.
Just 320, right? No x on that one? When I add up, when I add up sophomores, juniors, and seniors, what does that give me? All of the students in the school. Good. All right, what do you want to multiply by to get rid of those nasty fractions?
15.
Okay. Remember, when you're picking that number, all right, you're just focusing on the bottoms of the fractions. But then whatever number you pick, it doesn't just get multiplied on the fractions, it gets multiplied by these things down here too. Okay? So, 15 times 2 over 5, that's going to be 30 over 5, which is 6. 15 times 1 over 3 is going to be 5. 15 times 320, I don't.
I got it. I got this.
400 and
Is that right?
probably. No, because it's a 15. There's no extra zero.
Yeah. There's an extra
15 times
That's right.
320. Oh no, you're right.
Is it 4,800?
Yeah.
Okay, just making sure. And then I see where you're coming from. There is a 0 because there's a 10 in there, right? It's just kind of hiding. And then 15 times x is 15x. Everyone okay with where I got all those from?
Yep.
The ones that people mess up on are these guys down here. Okay, so watch out for those. And then we get 11x plus 4,800 equals 15x. Subtract the 11x, so 4,800 equals 4x, and divide by 4, and you get 1,200.
I have to go for an appointment.
Oh. Yeah, go ahead, Macy.
Yay for mental math.
Test tomorrow. Okay. James.
I did that like completely different when I got the
Okay, tell me about what you did, because there's absolutely more than one way to do it. Guys, can we simmer down a little bit? Go ahead, James.
So I added sophomores and the juniors as a fraction.
Okay,
11/15.
okay.
So then 4/15 was how much the seniors were.
Mhm.
And then I divided 15 divided by 4.
Perfect.
And then
Yeah, so you worked with this really more like you kept them in fraction form, and then you figured out what portion out of, like what fraction would those seniors have to represent, and then work backwards from there. That's a perfect way to do it, okay? This is for some of my like fraction phobia people who are not fans of fractions, but if you're okay working with them like that, that's absolutely a valid way to do it. Nice job, okay? Probably time for one more, maybe? Oh, let's throw in one more. We can do it. What do you want to do? Or is there nothing else? Are you feeling good?
We're feeling. You go over
Tessa?
I was gonna say like 25-ish areas that you gotta just like.
Okay, let's talk about, because I got a lot of questions on 25. I'm going to try to squeeze 25 in right here just so I don't have to use a new page. 25, guys, you're going to want to pay attention to this because this is something I think people are going to miss. 25 is an explicit formula. It gives you this. T of n equals 20 plus 3n. So it's not recursive. It's not that you're adding something to the previous term. It's that you just plug in what term you want. This is the instant gratification thing. okay, where you want term number 1, you put in a 1. You want term number 2, you put in a 2. So if I plug in a 1 for term 1, that's 20 plus 3 times 1, that's 23. So your first term is 23. Okay, for term 2, I would plug in a 2. Term 3, I would plug in a 3. Let me show you a thing on the calculator real quick that's going to help you with that.
Oh my god.
Okay, some of you may know this already, but.
Oh my gosh.
So let's say for that first one that I had plugged that into my calculator. So 20 plus 3 times 1. I really hope you wouldn't have to, but if you did, there you go. There's your first one. Now for the second one, what's the only thing that needs to change?
The 2.
Okay, if you hit second and enter, so hit second and then the enter button, it brings up what you typed in last, but it makes it so you can edit it. So I'm just going to go back to that 1 and change it to a 2, and there's my next term. Okay? Second enter, brings it up again, change it to a 3, there's my next term. Second enter, make it a 4, there's my next term. See how I'm doing that? So just to save you the time on your calculator so you don't have to retype it every single time if you're just changing one number. But that's how an explicit formula works. You want term 1, you plug in a 1. You want term 2, you plug in a 2. You want term 300, you plug in a 300. Good? Okay, I will post this tonight along with those answer keys. Please make sure you use those.